Hi guys, this is Mrs. Rooker. Go ahead and pause the video and do problems number 1 and 2, and then I'll put the answers up there. Okay, here are the solutions. Number 1 was C. You're going to use this formula. Oops, that was my eraser. This is the difference of cubes formula. That's supposed to be a cube. There we go. So you'll use that formula for number 1. And then for number 2, you would graph both graphs and see how many times they cross. You can see here they only cross one time here, which means they have one real solution. So today we are doing long division and synthetic division. So before we do that, we are going to review basic long division that you probably learned in elementary school. So if you remember basic long division, you can pause the video and do this one on your own. Otherwise, you can watch me for a review. So we line the 45,436 under the square root symbol, and we put the divisor on the outside. The thing that we're dividing by goes on the outside. Then we look at the divisor, 8, and we see how many times it goes into this first digit on the left. Well, 8 doesn't go into 4 evenly, or it doesn't go into 4 at all, so then we have to actually look at the first 2 digits. 8 does go into 45. It goes into 45 5 times with some left over. Then I multiply. 5 times 8 is 40. I line that under the 45, and then I find the difference between these two to find what was remaining. And the remainder is 5. Then I continue this process. I bring down the next digit and start the process all over again. How many times does 8 go into 54? That answer should be 6. 6 times 8 is 48. And then I subtract. Let's see, that is going to be 6. Bring the 3 down and start the process all over again. How many times does 8 go into 63? That answer is going to be 7. 7 times 8 is 56. Subtract that and we get 7. Bring the 6 down. 8 goes into 76 9 times. And then I subtract those. I get 4. There are a couple of ways that we could proceed after this. We could put a decimal there and continue. But I'm going to actually just write this as a remainder and make it into a fraction. So the remainder is going to be 4. And then we put the remainder over whatever we're dividing by. So the remainder is going to be 4 over 8, which actually can reduce. So this is going to equal 5,679 and 1/2. All right, and then we'll use that to kind of help us with long division of polynomials. We're going to set this up the exact same way. We're going to have a little division bar, and then on the inside we'll have the polynomial 3x cubed plus 4x squared minus 3x plus 4. And then on the outside we have the divisor, x plus 1. Really important whenever you do this, you want to make sure that all of your terms are in order by degree. So standard form with the largest degree first, and then it needs to go down from there. And you don't want to be skipping any degrees. So you can see here that this had 3rd degree, then 2nd degree, then 1st degree, then this would be considered 0 degree. So it went 3, 2, 1, 0, which is exactly what we wanted. If it was skipping any of the degrees, we would put a placeholder in there just to kind of keep our work a lot more organized. It'll make your life a lot easier if it's organized. All right, now we kind of just do the same process. We see how many times this, oops, I meant to highlight, this goes into these first two terms. But really, I don't look at both terms. I just look at the first term of the divisor and see how many times it goes into the first term on the polynomial. So in order to see how many times x goes into 3x cubed, I basically just think about what would I have to multiply x by to get 3x cubed. Well, obviously I'd have to multiply it by a 3, and then I'd also have to multiply it by an x squared, because if I multiply x times x squared, I get x cubed. So 3x squared is what I would have to multiply x by to get 3x cubed. Then what I do is I take that number, or that term, the 3x squared, and I multiply it by the entire number on the outside. So 3x squared times x is going to be 3x cubed. And then I also multiply 3x squared by the 1. So 3x squared times 1 is 3x squared. Then, just like with long division here, I had subtracted those two numbers. I'm going to do that exact same thing here, but I need to make sure to distribute a negative to all of my terms. So both of these terms are now going to be minus, or negative. And then I subtract. These first terms should always cancel. That means I did it right. And then the second one, I'll get a remainder. 4x squared minus 3x squared is 1x squared, or just x squared. Then, just like with normal long division, I bring down the next term. So I'm going to bring down the negative 3x. And then I try this whole process all over again. I see, I'm going to make sure I erase this so you can see where I'm pointing. Oh. Let's use x plus 1. Okay. So I look here just at the x, and I see what would I have to multiply x by to get 1x squared, or just x squared. I would have to multiply that by x. So that's going to be my next term. I'll put a plus in between them because my answer is going to be a polynomial, so I'll put plus x. Then I take that x and I multiply it by this whole thing, and I line it up down here. So x times x is x squared. X times 1 is going to be x. Oh, I'm not going to put that plus in there. I'm just put x. Okay. Then I'm supposed to subtract all of this, just like I did in regular long division. So I need to distribute a negative to all of the terms. These first terms should cancel. Negative 3x minus x is negative 4x. And then I bring the last term down. And do the whole process over again. What would I have to multiply x by to get negative 4x? The answer is negative 4. Now I multiply this entire thing by negative 4. I get negative 4x. And then negative 4 times 1 is negative 4. Now this is the part where students mess up a lot. I was supposed to subtract this from what was above it. But when I subtract, I need to distribute a negative to everything. These were already negative. Now they need to become positive. They always need to be opposite of what they were because I'm subtracting them. Subtracting a negative becomes positive. What's going to happen here is a little interesting. Oh, actually, no, it's not. These will cancel, and then I have positive 4, and positive 4 gives us a remainder of 8. All right, just like normal long division, the remainder goes on top of whatever the divisor was. The divisor was x plus 1. I'll just put a little plus sign in front of that. So my answer is a little ugly. I apologize. My answer is 3x squared plus x minus 4 plus 8 over x plus 1. Right, and then go ahead and pause the video if you need to kind of catch up on any of that. All right, so long division can be time-consuming, and it's hard to remember all the different steps sometimes, but if you ever forget, remember, just think back to regular long division, because it's the same process, just involving polynomials instead of just digits. All right, so now we're going to divide these using synthetic division. And you've already learned synthetic substitution so far this unit, so this will make this a lot easier. So just like with synthetic substitution, you are going to line up the coefficients, but you need to make sure that your polynomial is in order by degree without skipping any degrees. So this was 3, 2, 1, 0. So we're good. We're in order by degree without skipping any. And then we just write the leading coefficients, just like with synthetic division. So with synthetic substitution. 4, -5, 3. Then, to find the number that goes on the outside, we take the divisor and we set it equal to 0 and solve for x. So subtract 2 from both sides, x will equal -2. So it typically will be the opposite of this number. Well, it will be the opposite of that number if there's no leading coefficient. We'll talk a little more about that later. All right, and then we just do the same process as synthetic substitution. Bring the number down, multiply, add straight down, multiply, add straight down, multiply, add straight down. Okay, then the difference between synthetic substitution and synthetic division. In synthetic substitution, you would say your answer is 21 and you'd be done. Synthetic division, I want a polynomial answer. I take all of these numbers down here and I turn them into a polynomial. The way I do that is I look at the degree that I started with, third degree, and the thing I divided by, which was first degree. If I divide something by third degree, or something that's third degree, by something that is first degree, I should end up with something that's second degree. So I know that my answer is going to be second degree, and I'm just going to turn these all into polynomials. This is going to be x squared plus 2x minus 9, and then this will be my remainder, which I always put over the thing that I divided by. So I'll go back and redo that one more time so that you can see where we have a little more room. So I had these numbers. I know I want it to be second degree, so I take this coefficient and I turn it into something that's second degree, so x squared, plus, then this one must be first degree, 2x, this one must be 0 degree, and then this one is the remainder, which we always put over the divisor. That will be my answer. So it's a lot quicker than long division would be. So let's try this again really quick with number 2. What happened there? All right, so we need to make sure this is in order by degree without skipping any. 3, 2, 0, which means I'm missing first degree. So 2x cubed plus 3x squared plus 0x minus 6 is how I'm going to think of this. So when I write this, it's going to be 2, 3, 0, negative 6. And then to find the number that goes in the front, I set this equal to 0, and I get that x equals 3. And then you can pause the video if you want and actually kind of do this process. See if you know how to do it. Or you can just continue watching me. Bring the 2 down, multiply, add straight down, multiply, add straight down, multiply, add straight down, which should be 75. Alright, so this is the part that's different than synthetic substitution, so pay attention. This had been third degree, we divided by something that was first degree, which means it's going to go down to a second degree now. So this will be 2x squared plus 9x plus 27 plus 75 over x minus 3. 75 is the remainder. It always goes over the thing that you divided by. All right, we're running a little tight on time, so I'm going to speed it up here. And I'm just going to do one of these examples really quick. I'm going to try to be quicker. This one's trickier. Whenever you have a leading coefficient on the divisor, it's going to be a little more complicated. So I'm going to start by just writing this as 1, 0, negative 4, 5. The 0 came because we didn't have an x squared term, so I needed a placeholder. Alright, and then this part. To find the thing that goes on the outside, I set this equal to 0. I get negative 3 halves. But that's making it seem like my factor was x plus 3 halves. Right? If I have negative 3 halves on the outside. So if I just do this and I treat it like normal, I divide it with the negative 3 halves out front, my answer is going to be incorrect because this algorithm is assuming that this was my 0, or this was my divisor. So instead, in the end, I need to tell it that there was actually a leading coefficient of 2, so I was actually dividing by 2 as well. So I need to divide everything by 2 in the end as well. So I'm going to do this and hopefully it'll make more sense after I do that. Alright, bring the 1 down, multiply, I get negative 3 halves, add straight down, I get negative 3 halves, multiply negative 3 halves times negative 3 halves is positive 9 fourths. Alright, then I need to add straight down, negative 4 over 1 plus 9 fourths. I need common denominators, so I'm going to multiply the first one by 4, so this will be 16 fourths. Negative 16 plus 9 is going to be negative 7 fourths. Okay. Then I multiply again. A negative times a negative is a positive. Multiply the top. 7 times 3 is 21. I'm just going to do this on the side. And then 2 times 4 is 8. Which I guess doesn't reduce, so I didn't need to do that on the side. 21 eighths. And then I need to add straight down. So I'm going to add 5 plus 21 eighths. Multiply top and bottom by 8 on this first one. I end up getting 40 eighths. Add those, I get 61 over 8. Alright, then the kicker here is I need to tell my polynomial that I was actually dividing by a 2, not just a 1 here. So I need to divide all of these by 2. I do not, however, need to divide this last one by 2 because this always goes over the divisor anyway. So it knows that it's being divided by 2x plus 3. So my final answer, sorry this is a little rushed, is going to be 1/2 x squared minus 3/4 x minus 7/8 plus, I'm just going to leave this because it's a little ugly, 61 over 8 over 2x plus 3. Alright, you will not have any that ugly. I apologize for the ugliness of that problem. But then go ahead, pause the video if you want to. Try the next one on your own. You will have to use 1/4 as your number on the outside, and then you'll have to divide everything by 4 in the end. So try that on your own, and then unpause the video, and I'll show you how to do that one. Okay, so this isn't quite done, but this is what I have so far. I set this equal to 0, and I got that x would be 1/4, so that's why I have a 1/4 on the outside. And then I need to tell my polynomial that I was actually dividing by a 4 here. This isn't the same as dividing by k minus 1/4. So I need to tell it that there was a 4 in front by now dividing everything by 4. Except for the remainder, which just goes over 4k minus 1. So 4 divided by 4 is 1, and then this is going to be x squared. Oh, these are supposed to be x's, not k's. Plus 0x plus 5/4 plus 1/4 over 4k minus 1. Don't need to actually write the 0 here. This could be just, x squared plus 5/4 plus 1/4 over 4k minus 1. Technically, you can reduce the 1/4 over 4k minus 1, but I'm not going to be too picky about that. All right. I've got to bust through a couple of these really quickly. Find the value of k that would make the remainder equal to 0. All right, so I'm going to set this up just the way I normally would, and I'm going to solve for what k would be. So 1, -2, k, and 3. Set this equal to 0. The number on the outside is going to be 3. And then I'll go through this whole process. 1 times 3 is 3. Add straight down, I get 1. 1 times 3 is 3. Add straight down, I get k plus 3, because I don't know what k is. Multiply, I get 3k plus 9, because I need to multiply this 3 by this whole thing, so it's distributing. Add straight down, these two are like terms, so those can combine, but the 3k stays separate, so 3k plus 12. Why did I put 18? Sorry, guys. 3k plus 12. And then I look at what the problem said. It says, what would make the remainder equal to 0? Well, this part is the remainder. So I'm going to see what k would have to be in order for the remainder to be 0. So add 12 to both sides, we get subtract 12 equals -12. Divide by 3, k equals -4. And then you guys should just try solving this one on your own really quick. You can pause the video and do this one, and then I'll just have the answer up there for you when you unpause the video. Here is your answer. So definitely ask questions if you have any in class tomorrow. Have a good one, guys.